Good morning and welcome. Today we are going to discuss lesson 1.6. The title of this lesson is Relations. So I want to talk to you about what a relation is. A relation is a set of ordered pairs, and it's important for you to know the different ways that a relation can be represented. It can be represented as a set of ordered pairs, as a table, a graph, and this last way that you never saw. So one more time, a set of ordered pairs, a table, and that should have an X in it, and let's just get out of the highlight, a graph, or a mapping. So let's go ahead and take a look at what we've got here today. So the set of ordered pairs would be 1, 1, 0, 2, 3, negative 2. As a table, the X values are going to go in the left-hand column, the Y values in the right. So my ordered pair 1, 1, 0, 2, and 3, negative 2. When you go ahead and represent them on a graph, I want you to start at the origin, which is 0, 0. The X coordinate, you move either to the right if it's positive, to the left if it's negative, and if the X coordinate is 0, you stay there. On the Y coordinate, if it's positive, you move up. If it's negative, you move down. So to graph the point 1, 1, I start at 0, 0. I move 1 to the right, which is the X coordinate of 1, and I move up 1 on the Y axis, and that's the point 1, 1. My second ordered pair is 0, 2. I am not moving. I am staying right at the origin for my X coordinate and going up 2. And my last coordinate is 3, negative 2. Positive 3 over 3 to the right, negative 2 down 2. Now when we form a mapping is extremely similar to a table. And what we are going to make sure we do is that we match the X and the Y. So we're matching them up. So how do I know what goes with what? You're going to draw an arrow from the X value to the Y value. So the 1 is matched with 1, 0 with 2, 3 with negative 2. I just want to bring you over here for 1 second and just show you something. So let's take a look. If I had this set, this relation, 1, 2, 1, 3, 2, 4. And I said, let's go ahead and represent that relation as a mapping. So if we wanted to do a mapping, it might look like this. So here's my X. Here's my Y. I have 1. I have 1 twice as my X coordinate. I need you to understand if an X value or a Y value repeats itself, it is redundant to put it in twice when you're doing the mapping. So I would only write 1 once, and I would write 2 once. My Y values would be 2, 3, and 4. When I go to map them to show you which X goes with which Y, my first ordered pair was 1, 2. Does everyone understand that that would be read as 1, 2? My second ordered pair is 1, 3, and that's how I would show that. Again, do not write the 1 2 times. It's redundant. And my third ordered pair would be 2, 4. Does anyone have a question? Okay, let's talk about the domain and the range. So let's just make sure, let's just go back up here to our definitions. All of these definitions are important. Please make sure you do know them. The first set of numbers in an ordered pair is called the domain values. So when we think about it logically, in the alphabet, X comes before Y. So the X value comes first. The domain is like the X value. The range comes second. The initials DR stand for doctor. Remember, Mrs. Urso was a doctor before she was a teacher. X comes before Y. The X and the domain values are the same. Y and range are the second value. and they are the same. Does everyone understand what the domain and the range are? Okay. If I said to you, determine the domain and range of the relation above. So let's go back one more time and let's just look at our original example. Our relation is the set of numbers 1, 1, 0, 2, and 3, 2. So my x values, or my domain values, would be the first number. So my x values, or my domain values, would be 1, 0, and 3. Does everyone see that? Yes? And what would my range values be? 1, 2, and negative 2. Now, please remember, if you have a domain or a range value that repeats itself, you do not list them 2 times. So let's let you go ahead and try. So in your notes, go ahead and let's fill this in. Express the relation below as a table, a graph, and a mapping. Okay, so they've done the graphing for you. So I want you to do it as a mapping and as a table, and then I want you to tell me the domain and the range. Okay, and you're going to do it right here. And tonight on your homework, that handout I gave you, you have my permission to do it on the handout. You do not need to do it on notebook paper. That handout was created to do on there. Does everyone understand? Okay. So you're going to write it as a table and as a mapping. So let's give you a minute and then we'll go over the domain and the range. And then we have a couple more things we're going to look at in the second half of the lesson on relations. And you are in great shape. So your x values go in the x box for your mapping. Your y values go in the y box. If you do not draw arrows, it is incorrect. Does anyone need more time? Okay, who would like to tell me what's going in the x part? Yes, Kylan. Negative 2, 3, and 4. What's going in y, Bella? Negative 1 and 3. Where am I going to draw my first arrow, John?
The negative 2 to the negative 1.
Negative 2 to negative 1. Second arrow, Joseph. 3, 3. And my last one, Justin. 4 to the 3. Does anybody have a question? Okay, Lauren, what did you put in your table? What was your first ordered pair? Give me the x and y. Negative 2, negative 1. Next ordered pair. Christian.
3 and 3.
Good. And the last one, Nicholas.
4 and 3.
4 and 3. Okay. Who could tell me what the domain is of this relation? What is the domain of this relation? Someone who hasn't answered a question. Go ahead, Avery.
Negative 2, 3, and 4.
Negative 2, 3, and 4. And what's my range, Abigail?
The range is negative 1 and 3.
Perfect. Does anyone have a question on a relation? So let's just think again the different ways to represent a relation. We can represent a relation as, what would be the first one? Okay, let's think about it. Before we even do that, it's a set of what? Yes. Set of ordered pairs. Please don't call out. Please raise your hand. Set of ordered pairs. Okay, the next one would be what? Anybody? Raise your hand. Someone who hasn't answered. Let's get somebody else involved. You can look. It's right in your notes, guys. Come on. You answered a question, right? I'm asking. Look, trying to find somebody who hasn't answered. Take it away. Yes, right here. Go. A table. Good. Class, what would be a next one? A graph. And the one we just learned that you didn't learn in pre-algebra? Mapping. I like mappings. Okay, so if you were asked to define a relation, And if you were asked to write the 4 ways that you could represent it, everybody would know. Does anyone have a question? Alrighty, here we go. Okay, so these are some other keywords for the x values or the x values. We could call it the horizontal value. That's not used that much. It's mostly used in reference to the horizontal axis. The domain values, the input, or the independent. So, if that's for the x, what would we fill in the... Do you have a question? Nicholas, you have a question? Okay. So the y values would be what? Who can give me one? Yes.
One would be
Well, let's put them side by side so it makes sense. What would go with horizontal? Yes, right here. Vertical is correct. What would go with domain? Yes.
range.
The range. What would go with input? In the back. Output. And what would go class with independent but nice? D-E-P-E-N-D-E-N-T? Luckily, I don't teach English. Okay. Good job. Anybody have a question? Yes. I used to cry when I had to write papers in college. Seriously. Okay. Lesson 1.6. Let's talk about relations a little bit more. The value of the variable in a relation that is subject to choice is called the independent variable. The variable with a value that is dependent on the value of the independent is called the dependent. Y depends upon X. So I'm going to tell you something here. Whenever we go ahead and look at graphs, Ms. Erso, I didn't know what to put on the X and I don't know what to put on the Y. Well, if you have time involved, okay, if time is involved, time is always on the x-axis. So I would write that. Time is always on the x-axis. So let's look at our first example. Example 1 and example 2 both deal with time. Okay? The graph below represents the height of a football after it is kicked downfield. Identify the independent and the dependent variable for the relation, then describe what happens in the graph. So, what is my independent variable, class, in this graph? My independent variable is what? Independent is always what? Time. The independent is always time. What is the dependent variable, John? The height. Welcome to class. There we go. It's okay. The independent variable is time. The dependent variable is height. How high the ball goes depends upon how long the ball is going to hang in the air. In football, there's a term called the hang time. Where are my football players? Any football players in here? The hang time. So a punter wants to have a really good hang time. In high school, a good hang time would be like 3.5 to 4 seconds. In college, it would probably be 4.5 to 6 seconds. And in the pros, probably a little bit higher. So there's just an example how algebra can be so practical and how we can relate it to something that we love and watch every day, and many of you take part in playing. So the independent variable is time. The dependent variable is height. The football, we all know, starts on the ground when it is kicked. It gains altitude or height until it reaches a maximum height. This would be the maximum height right here. After it gets to a certain point, guys, the ball just doesn't continue going to the sky, up, up, up. What goes up must eventually come down. And hopefully the person who is receiving can catch the ball and not fumble it. So it gains altitude, it reaches a maximum height, and then it either falls to the ground or someone receives the ball. Any questions? This graph below represents the price of stock over time. Identify the independent and dependent variable for the relation, and then let's try to describe what might be happening in that graph. So this could be related to stock, to bonds, even to like our checking account, what happens, okay? So what's my independent variable, class? Nice. If time is involved, it's always the independent variable. And my dependent variable would be what? The price. So you bought stock, say, at a very low or reasonable rate, and the stock market was doing great. What was happening to your value of your stock? Was it going up or down? It was going up steadily. And it reached a certain point or a certain price, and then what happened? It started to come back down. You're still above what you bought it at, so you've still made money. And now what happens? Now the price starts to go back up again. So the independent variable is time. The dependent variable is price. The price increases steadily, then it falls, then increases, then falls again. Does anyone have a question? So, identify, did I give you these as part of your homework? I think so. Page 9. Okay, well, let's do them together. You ready? Yes? Okay, so let's do these three. Identify the independent and dependent variables for each relation. Then describe what is happening in each graph. So number 1, this graph represents the speed of a car as it travels to the grocery store. So the first thing I want you to put is the independent variable and then the dependent variable. And then I want you to write what's happening. Okay, so in number 1, what is my independent variable, class? And what's my dependent variable? Good. In number 2, what's my independent variable? And what's my dependent variable? Account balance. Or dollars. That's fine. How much money you have. And in graph number 3, what's my independent variable? And what's my dependent variable? Okay. So, who would like to take a shot at what might be happening in graph number 1? Graph number 1. Alex. Very good. So right here at this point, the car has not been started. The car starts. It increases at a steady speed. Then it maintains a speed for a while. Maybe it came to a traffic light or a stop sign, and then it slows down and eventually stops. Great job. Good job, Alex. Number 2, this represents the balance of a savings account over time. So who would like to explain what's happening there? Go ahead, John, try.
The amount of dollars rises,
Mhm.
then it stays the same for a little bit, then it rises again, and then it starts to lower a lot.
Okay, so why might it raise? Why might your account balance raise? What could have happened? You could have gotten paid, could have gotten a big bonus. Then it stays the same. You're not spending any money. You're not have any automatic withdrawals from your account. You're not paying any bills. Then you get paid again, and the account balance goes up. And then all of a sudden, wow, it goes down until there's nothing left. You had to pay the mortgage, you had to pay the electric, you had to pay the water, you had to pay the garbage, you had to buy groceries, you had to give out gifts, and your account balance went down. Is that helpful? Okay, good. Number 3, this graph represents the height of a baseball after it is hit. So let's just think about, anybody in here play baseball? Okay, so when the pitcher pitches, I'm going to pitch underhand as a scenario. The pitcher pitches, you're not hitting the ball on the ground. You're hitting the ball and it's up in the air. So say the ball is right here. So you swing You make contact, and what happens to the ball? It goes up in the air, unless you hit a grounder. But in this particular graph, the ball went up in the air, so it was a fly ball. And then it eventually comes down. Either someone catches it, or it's a home run out of the field, over the fence, kind of hit, and we're happy. Okay, does anyone have a question? Okay, that is relations. Let's look at our homework page for tonight. So we did those. So we did page 8 and page 9 together. So your homework tonight, did everyone receive this? 9A and 9B. Those of you who are listening online, if you are not here today, please ask a friend to send a picture or email me, and I'll send you a picture of the worksheet. So let's look at 1, 2, and 3. Express each relation as a table, graph, mapping, and the domain and the range. Do you understand? People that came in late didn't get one? Do you understand that there are 4 answers? Yes? Okay, they're going to count as 4 separate questions. I already said you're going to do it right on here, Justin. One more time, look and listen. Guys, I'm giving you permission. Your homework does not have to go on notebook paper tonight. It can go right on here. So on 4 and 5, you're going to tell me which one is independent and which one is dependent. Turn the page, 9B. 1, you're expressing that relation as a table, a graph, a mapping, and determining the domain and the range. Make sure you answer all 4 parts. Number 2 and 3, describe what's happening in the graph. Number 4, 5, and 6, you're giving me the relation as a set of ordered pairs. And number 7, you can just have some fun with. Does anyone have a question on the homework? All right, guys, have a blessed day.